Hi viewers, this is Kasturi Day. Today I'm back with the motion in one dimension chapter according to ICSE syllabus class 9. Okay. So in my last video, I stopped with the equations of motions. What were the equations of motions we were discussing about? Yes. See the three equations. There are three equations of motions which are also known as laws of constant acceleration. Okay. And these equations are derived from the components like displacement, velocity, time, and acceleration. Okay. So velocity can be initial and final both. Okay. The three equations which are the which we will be discussing. The first one is v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is acceleration, and t is time. Then the second equation is S is equal to half into U plus B into T. Okay. Or you can say UT plus half AT square. Okay. Where S is the displacement and U, as we know, it's initial velocity, B is final, and T is what? T is time. Or you can say this one. A is acceleration ut. Ut means what? See, if you multiply like this with t, then it will become ut plus half at square. Okay. So this is the equation. Then next, third equation is v square is equal to u square plus 2as. Okay. Where s is displacement, u is equal to initial velocity, v is final velocity, and a acceleration, t is time. Okay, you can say SUVAT, S-U-V-A-T. These three equations can be named, referred to as SUVAT, where S stands for displacement, U stands for initial velocity, V stands for final velocity, A for acceleration, and T for time. Okay. So next we move on to these equations. How are they derived? Okay, the first equation is V is equal to U plus AT. Okay. So in the first, we will discuss the graphical method, how this equation is derived. Okay. So from the picture, you can see there two axes are there. That is, one is a y-axis, which is represented by velocity, and that is v, final v, and okay, and then the x-axis is represented by time. It's a time axis, and the y-axis is velocity axis. Okay, so it's a velocity time graph. Okay, now see OD is initial velocity. OD is initial velocity, and OC is the final velocity. Again, OE is time. Okay. Now, let's move on. First, we will see that let OD is initial velocity, that is U. OC is final velocity, that is V. And OE, that's time. OE is equal to dA from the graph. You can see OE is equal to dA, and that is equal to what? That is equal to T. Okay. And uniform acceleration, that means that is A. We consider it as A here in this graph. Okay, from the graph, BE is equal to BE. Okay, this one, this side, BE. Okay, BE is equal to what? BA plus AT, right? Sorry, BA plus AE. Okay, BA plus AE. Okay, or AB plus AE. Yes. Then what is this? BE. BE means what? That's velocity V, capital V, total V, velocity. Okay. So V is equal to, we know if we consider this one, V is equal to CD plus or DC plus OD, right? DC plus OD, that becomes the total V. Okay. Now, as we see from the picture, DC is equal to AB, DC or CD is equal to AB, and OD is equal to AE. Therefore, we can use this one as in place of CD, we can write BA, and in place of OD, we can write AE. Okay. Now let's see that DC, we keep it as DC, and in place of OD, we are writing as initial velocity, that is U. OD is U. Okay, small u. Therefore, it can be written as capital V is equal to dc plus u. That's one equation, first equation. Second equation, as acceleration, we know acceleration from the acceleration is equal to v minus u by t. Acceleration is equal to v minus u by t. Okay, so what is v here? V is c o. OC, or you can say OC minus OD. OC minus OD is what? And divided by T. Okay, so OC minus OD means what? CD or DC. Okay, so DC by T, or you can say if you take T from this right hand side, sorry, left right hand side to left hand side, then we can say that AD is equal to DC. This is another equation, second equation. Now, if we substitute both this, 2 in 1, this AD value is DC. Okay. Now, if we considered in place of DC in the first equation, if we put the value of AT, okay, then what happens? If we write in place of DC, we write AT. Okay, and it remains like that. So that means it becomes what? In the first equation, we see V is equal to DC plus U. So in place of DC, we write AT. So it will become what? V is equal to AT plus U, or you can say, you can write that V is equal to U plus AT. Clear now? How did we derive the first equation from this graphical method? I think it's clear, okay? So let's move on to the next equation, that is the second equation by the graphical method itself. So in the second equation, again from the graph, we see the same graph is there. That is OU, or OD is U and OC is V. Okay, this is the velocity axis, and this is the time, that is y-axis is velocity axis, and time axis, that is OE, is the time axis or x-axis. Okay, and this one CD is parallel to BA and it's equal, whereas OD is parallel to AE and it's equal to that. Okay, so like that, from the second equation graph is what? S is equal to half into what? UT plus half AT square. Okay, we know that half AT UT plus half AT square is what? Our this one, S. So again, it's a velocity time graphs. Let's say OD is equal to U, initial velocity. OC is the final velocity, that is V, and OE is equal to dA, that's time, and uniform acceleration is A. The distance covered the given time t is the area of the trapezium. See, from the trapezium, we see that is first it's moving like this. OD is moving initially, and then it's moving away from the y-axis. First it's moving along the y-axis, and then it's moving away from the y-axis, and it's increasing its velocity. So what happens? It forms a trapezium. Okay. So what is the area of the trapezium? AB, excuse me, ABDOE. This is the trapezium we will consider. Okay, now distance is what? S. S is equal to what? Area of ABD triangle and the area of ADO. Okay, that's a rectangle. Now what do we do? As we know, S is equal to half into AB into AD. Okay. See, we are finding out S. Now, how to find area of ABD? ABD is what? Half into base into height. So base is what? AB, and height is what? This one, AD. Okay. So to find the area of this triangle, we make what do we do? That is half into base into height. So we consider half into AB in base into height is AB, right? And area of ADOE, that's a rectangle. So length into breadth is the area of the rectangle. So what do we do? OD into OE, length into breadth. Okay. Now, as AB is equal to DC, as we know that AB is equal to DC. Therefore, we in place of AB, we can write DC. Okay. So what do? We in place of AB, we are writing DC and AD is remaining like that. So half into DC into AD and that plus UOD into OE, OD into OE. In place of OD, we can write U because see OD is U, it's given. So like that, we can write in place of OD, we can write what? Small u, that is initial velocity. And in place of OE, we can write small t, that's time. OD is equal to, this one, OE is equal to dA is equal to t. It's given, no? So OE in place of OE, we can write small t. So what it has come now? U into t, that is UT. Okay. Now, DC into AD. DC into AD. DC into AD. So DC into AD what? In place of DC, we can write what? AT. Why? See, as DC is equal to AT. Why DC is equal to AT? DC small AT, not capital AT. See, small AT. So why DC is equal to AT? DC means what? DC means what? DC means V total V minus total U. What is it? That is AT. See, from here you can see one more thing, one more step. Sorry, third equation. Okay, so DC means what? DC means CO or OC minus OD, and OC is what? Capital small v, and OD is what? Small u. So V minus U is what? UT. So sorry, AT. And from the first equation, see, AT is equal to DC. It's written here. So we can say DC is equal to AT. Therefore, in place of DC, we can write AT. Right? So what does the equation come now? That S is equal to half into AT into T. In place of AD, we can write T because AD is equal to OE and that is equal to T. Right? So in half into AT into T plus UT. So you can say half into AT square plus UT. T square, that is multiplying again with T. So AT square into T, or you can say UT plus half AT square. The second equation is derived from the graph. Clear? Next, we are moving to the third equation. So here also the same graph is there, velocity time graph, same measurements and everything is same. Only thing is that now OD, the third equation, what was the third equation? That V square is equal to U square plus 2AS. So we need to derive this from the graph. Okay. So OD is equal to, we know its initial velocity, that is U. OC is final velocity, that's V. OE and the OE is equal to dA, that's T. That's time. Uniform acceleration is A. So distance covered in the given time in the area of the trapezium, what? AB, DOE, right? Now, let in the given time, the distance covered is S. Now, area of the trapezium, total area we need to find out. So what do? Half into sum of the parallel sides. So we take the trapezium area. How do we find it? So half into sum of the parallel sides. What are the parallel sides? Parallel sides is DO and BE. Okay, DO and BE. So we make a sum of these two and multiply it with OE. Okay, distance between the parallel sides. That is the formula of the trapezium, area of the trapezium. That is half into sum of the parallel sides into distance between the parallel sides. So distance S is equal to half into DO plus BE into OE. So DO, what is DO? That is U. Okay, and BE BE is equivalent to BO, equal to CO. Okay, BE is equal to CO, and that is equal to what? That is equal to small b. So V plus U, sorry, U plus V into T. That's the third equation we calculate. So from the equation 2, that is U is equal to, A is equal to V minus UT, we can say what? T is equal to V minus UA. Okay, T is equal to, we separate T. Okay, so we move T this side, we keep this T this side, and what do we do? Sorry, there's something wrong in this. It was V is equal to U plus 80. Okay, that we know. V is equal to U plus 80. Okay, now we want to separate T. So what we'll do, see from the equation, thing, no? A is equal to V minus U by T. U minus U by T. So T, if we go there, A comes the side. Okay, that means what? T is equal to V minus U by A. By A. Okay. So it will not be into T, but it will be by. Okay. So V minus U by A. That's divided by A. Okay. So by substituting the equation 4 in 3, we will do what? S is equal to U plus V. Okay, U plus V into V minus Q by A. Okay, now therefore what we'll do, what will happen like this, A will move on to this side. Okay, A moves on to 2 because A is dividing there. So this will move on to this side. That means 2 half is there. No, so half 2 also will move to this side. A also will move to this side as they are dividing. Okay. So here on this left hand side, if we move, that will be getting multiplied. Okay. So what will it happen? It will happen in like this. It will become 2AS is equal to V plus U into V minus U. So A plus B whole square, what is the formula? A plus B into A minus B. Or A minus B whole square means what? A minus B whole square, A square plus A plus B, sorry, A square minus B square. Sorry, I'm sorry. The formula is A square minus B square. The formula A square minus B square means what? A plus B into A minus B. So that is the formula, V plus U and V minus U. So we will get V square minus U square. Okay. So A plus B is given, A plus B and A minus B is given. If we multiply them, what do we get? A square minus B square. Okay, and 2AS is there. So what will it come? V square, V square plus 2AS. Sorry, V square is equal to U square plus 2AS. Clear? Only thing is that, only the wrong thing is that it should be division. There will be a division sign, V minus U by T, and here also V minus U by A. Okay, and here also A is dividing. A is not multiplied here. Acceleration will be divided downwards. It will be a denominator. Okay, here also acceleration will be a denominator, not numerator. Okay, so this is the thing. So next we move on to the derivation of the equations of motion. Again, this is by algebraic method. Simple algebraic method. First one was graphical method, and now we move on to the algebraic method. Okay. Now by definition, as we know, the rate of change of velocity is the definition of body acceleration. So acceleration means what? The rate of change of velocity. Okay? And if it is assumed that the body has a mass of m and initial velocity is small q, and after time t, its final velocity becomes v. So due to uniform acceleration A, then the acceleration will be final velocity minus initial velocity, final velocity minus initial velocity by time. Okay, that means A is equal to V minus U by T, or it is equal to V minus U. That means V is equal to U plus AT. Simple algebraic method. Clear? Next, second equation is distance we know is average velocity into time. Okay, average velocity into time. So average velocity what? V plus U, initial velocity plus final velocity divided by 2. That will give the average velocity, and that is multiplied by time. So what is distance? Distance is S, represented as S. So S is equal to U plus V by 2 into T. Okay. So what if we change it, that is from U plus this one, if we in place of V, and we know from the first equation that is V is equal to U plus AT. So in place of V, you can write U plus AT. Okay. So what do we do? S is equal to U. S is equal to U. In place of V, we write U plus AT divided by 2 into T. That means what? 2U plus AT divided by 2 into T. Or you can say 2ut plus at square by 2. Or you can say 2ut by 2 at square by 2. Or s is equal to ut, that is 2 cancels here. And here it remains what? Half. Okay. So ut plus half at square. Write it down in a paper, and then you will be able to understand this formula. This formula, just step by step, you write it down. You can understand how this equation, and as I'm telling you, you please write it down in a paper. In your copy also you can do it. And then you will be able to understand what is happening there. Okay, unless and otherwise you solve it, you write it down with the pen, you will not be able to understand properly. So please write it down as I'm telling you. So then you will be able to understand what is happening there. Next is third equation. Distance is equal to average velocity into time, we know. So the third equation is V square is equal to U square minus 2S. So from the first equation, V is equal to U plus AT. Hence, it can be written as T is equal to U minus V by A. Okay. Now, also it is known for constant acceleration. It can be written average velocity is equal to final velocity plus initial velocity by 2. That is V plus U by 2. Okay. So, distance is equal to what? S is equal to what? Average velocity into time. So, see, in place of average velocity, we write V plus U by T. And in case of time, we write what? V minus U by T. U by A. Okay. So in place of, see, as this equation is this in this equation, see, distance is equal to average velocity into time. So in place of average velocity, what do we write? V plus U by 2. And in case of time, we write this one, V minus U by A. Okay. Now what do? We solve it. That is V plus U, okay, into V minus U divided by 2A. So V plus U into V minus U, what will it come? V square minus U square by 2A. So 2A will move this side, that is towards left hand side, towards S. So it will become 2AS is equal to V square minus U square. Or you can say v square is equal to u square plus 2as. See? So if a body starts from rest, initial velocity u is equal to 0, then v is equal to 80. Okay. If a body starts from rest, that means its initial velocity will be 0. So there will be no u. Okay. So what happens if there is no u? Then what was the original formula? V is equal to u plus 80. So if this u becomes 0, then what it remains? V is equal to 80. This one is the formula. V is equal to 80. Second formula, what was it? S is equal to ut plus half at square, right? If u is not there, so the multiplication with t, that also will become 0. So what happens? What does it remain? Then s is equal to half at square. Third equation, v square is equal to u square plus 2as. Here also, if u becomes 0, then its u square will also be 0. So therefore, what it remains? V square is equal to 2as. Right? Next, if a body is moving with uniform retardation, that means acceleration is negative. A is negative. Then what happens? This formula, that is V is equal to U plus 80. Here it becomes V is equal to U minus 80 as A is negative. Second equation also, as S is equal to ut plus half 80 square. So it will become S is equal to ut minus half 80 square. Third equation also, v square is equal to u square plus 2as. 2as is the original equation. As acceleration is negative, that is retardation, so it will become v square is equal to u square minus 2as. Clear? Okay. So next will be, this is the end of the chapter. In my next video, I will discuss what? This one. ICSE specimen question answers. So before I end, I will request you to please to meditate before you start your day, and also do subscribe and do ring the notification bell, so that as soon as you as soon a new video is uploaded, you get the notification. And also, if you are liking the video, press the like button, share with your friends and colleagues so that they can also be benefited from these videos. And again, do not forget to meditate. Okay, I have not started meditation today as I started the video, but you all please practice the meditation when you start your videos. I mean, when you start your studies, when you start your day, whatever you do the whole day, that will go very accurately, I would say, if you do start your day with the meditation, and you will be very successful. I'm really telling you, it will be very helpful to you all. Even my daughter is being benefited from these meditations. So please practice. It will be a great help to you all. Okay? So thank you for joining, and have a good day.